Good morning, everyone. I am Lubinder of AML Department, Savita Engineering College, final year, and I am presenting my project, which is RAG for Multi-Tool Integration and Smart Workflow. This project focuses on improving the reliability of large language models by combining them with external knowledge sources and intelligent tool usage. Instead of depending only on the model's internal knowledge, we ground responses using retrieved documents and tool outputs. It significantly reduces incorrect and hallucinated answers. So, if you're talking about the agenda, these are the agenda that we have included in our project presentation. As I said about the introduction, RAG, which means Retrieval Augmented Generation. It is an advanced approach that improves the reliability of LLMs by grounding the response to external sources so it doesn't hallucinate and provide inaccurate answers. Modern AI applications requires integration with document retrievers, calculators, APIs, and all these databases are as vector databases in a RAG model. Our project basically focuses on building the smart workflow that combines RAG with multi-tool integration for better and accurate answers and responses. Statement of the problem. So, traditional large language models work in isolation. They often generate answers that sound correct but may not be factually correct, especially when real time or domain specific information is required. Also, integrating external tools like document search, calculators, or APIs manually is complex and not scalable in other models. So, there is a clear need for intelligent system that can automatically decide when to retrieve data and when to use the tools to generate accurate responses. This is the problem my project aims to solve. So, scope of our project. The scope of our project is to design and implement a RAG-based intelligence system with including multi-tool integration and smart workflow orchestration. So our functional scope would be like retrieve the relevant documents from a vector database and integration of tools like retrievers, calculators, and APIs. In path of technical scope, we use embedding models, vector database such as FIRES and Chroma, and also tool calling enabled LLMs. And finally, modular and extensible architecture is based on a project. So the user application scope, yeah, technical scope. So the user application and scope is like it is simple and interactive interface, and our responses are evidence based accurate answers. So our RAG model is applicable in education, research, enterprise, and technical support systems. So if you're talking about methodology of our project, it consists of five major steps. Data ingestion and pre-processing is the first step. Um, so first, relevant documents are like collected from multiple sources and cleaned, and they are divided into smaller chunks for better retrieval. The second step is like embedding generation and vector storage. So these chunks are converted into vector embeddings and stored in a vector database. Next, the user query understanding. So the system analyzes the user to understand the intent of what the user is trying to convey or what he needs. Next, the another one is intelligent tool selection. Based on the intent of the user's query, the system dynamically selects which tool is required, such as document retrieval or calculation. And finally, the RAG is based on response generation. The retrieved context and the tool outputs are passed to the LLM to generate a ground and actual response. So this is our architecture diagram and workflow. So this consists of a user interface and it passes on to the intelligent agent, and then a vector database is there, and also we have added a multi-tool integration layer and LLMs. So the workflow starts with the user input followed by retrieval or tool execution and finally response generation using RAG. So we have given UML diagrams shows how users interact with this AI assistant, and also class diagrams which represent the system structure and object relationships between them. Our sequence diagrams Um, so our sequence diagrams explains the step-by-step interaction flow between components. And basically these diagrams help to understanding functional and structural design. Next, the algorithm used. The main algorithm is RAG, which is retrieval based augmentation. But the second main algorithm is the Randos forest classifier. It is an ensemble learning that builds models multiple decision trees and gives output based on majority voting. It reduces overfitting, handles noisy data well, and provides stable and accurate predictions. This makes it suitable for intelligent decision making tasks within the workflow. Hardware and software requirements also is there, and basically the hardware requirements is like an Intel i5 processor or higher minimum 8 GB RAM, SSD storage, and internet connectivity. And then the software recommendations would be like Python 3 and frameworks including LangChain, Llama Index, and vector database that we use, as I said, is Fires and Chroma. And the LLMs which we are using are Grok, OpenAI, and Gemini LLM. And the view front end, which is a UI, we have used the Streamlit front end, and our IDE is VS Code, Visual Studio Code. So the implementation in phase is like the first step would be documents are collected, cleaned, chunked, and embedded. And the embeddings are stored in a vector database, and then the user queries are analyzed for intent. And then the intelligent router or agent selects the appropriate tool for that command. The relevant content is then passed to the LLM. Then finally, the LLM reduces the hallucinations and generates a perfect response for the user. So these are the important code segments that we have included in the RAG model. So this contains the vector database creation, similarity search, LLM agent construction using Grok and Llama 3, and then integration of retrieval and generation, and Streamlit based conversational interface. Finally, the output. So the system provides an ultra low latency document retrieval, unlike standard AI that thinks before it speaks. So yeah, and then a fact grounded verifiable answers, which is an anti hallucination, which means there will be no hallucination and exact accurate facts. And multi-modular semantic orchestration, which means modular design allowing easy tool expansion, and conversational and persistent chat interface. So this is how our dashboard page looks like. So multiple test cases were executed including e-commerce based queries. The results shows improved relevance, faster response time, and better user interaction compared to traditional systems. Yeah, this is a document retrieval, as I said about the results. And in conclusion, mm, to conclude, this project successfully demonstrates a retrieval augmented generation based intelligence assistant. By grounding responses with retrieved knowledge, hallucinations are reduced, reliability is improved, and the system becomes suitable for real world applications. So, for the part of future work, we plan to add long term conversational memory and implement role based access control, enable real time web search in our model, and also deploy using cloud and containerization. And we would also like to improve retrieval using hybrid search techniques. Thank you. And thank you for giving me this opportunity to present my projects. Uh, I think this is the presentation. Thank you.